Today's video review covers determining the area of a polygon. Now, if you were to look at polygon A below, you might get scared. But does it scare you to determine the area of a rectangle? At least in sixth grade, you've learned prior to sixth grade how to calculate the area of a rectangle, and that's all you need to do to be able to determine the area of this strange-looking polygon. Let me take a look here at a zoom length of 100% and utilize my toolkit to the right here and take one rectangle and place it over the blue shaded area or part of the polygon. What we can see when we use a grid is that the height of this rectangle is 5 units. And then we can also see that the base length is 2 units wide. And that's why it's useful to draw polygons on grid paper. If we take another rectangle and place it over this other area, it has a dimension of 2 for a base and 4 for a height. So those are the 2 dimensions. And then finally, a third rectangle, which turns out to be a square, 2-sided by 2-sided, also fits this remaining area. So while this doesn't cover the polygon completely, I think you get the idea. So if we were to take the area of each of the rectangles and add them together, and we take 10 square units, the 2 times 5, the base times the height. So this first yellow rectangle, we get 10 square units. And for the green one, we get 8 using the same formula. And the purple one, we get 4 using the same formula. We can add these square units together of each of those rectangles to add up to 22 square units. Now, like we've learned in math, there's more than one way to peel a potato or even to prepare a potato. And there's more than one way to solve a math problem. As we look at determining the area of this polygon, we can also use subtraction. We can use the same idea with rectangles and determining the area of rectangles. But instead of using addition, in this case, we're going to use subtraction. So I've taken a rectangle that I've already prepared that covers fully the area of this polygon, again shaded in blue. You can see what is in white is the area that's outside of the polygon, but inside of this large rectangle. Now this large rectangle has a base of 6. You can count across 6 squares in the grid, and you can count again 5 up for its height. That is the red rectangle. And then we can insert, or at least visually just determine that we have a rectangle that's 1 by 2. And that's in red, of course, or maroon. And then in gold, we have another rectangle that has a base of 2 and a height of 3. So what do we do here? Well, again, we take the large rectangle and we subtract the areas that were covered in white, but now I've added these other rectangles to help us see it better. And if you subtract the areas of these 2 rectangles from the area of the overall rectangle, so subtract out that space, and you are left with the area of the polygon. So again, I've already prepared a sentence, or rather a formula, an equation that represents this phenomenon where you have a rectangle area of 30, subtracting another rectangle with an area of 2, subtracting another rectangle with an area of 6, and you get the same 22 square units that you found when you added the rectangles that covered the blue part or the blue polygon. So for extra practice, what we would like you to do is to find the area of the shaded area in one below And you can see it's somewhat similar in size or in structure to the one we just looked at. And for extra credit, see if you can determine the area of this blue part. Don't include the white, but how would you determine the area of that for extra credit? Good luck.